Hello everyone. We want to introduce vector fields. Now vector fields are vectors in 2 or 3 dimensions, and they are vectors of functions in this form, which of course we can just shortcut like this, or in this form, and they generally always represent force. So the idea of a vector field, it's a vector representing force. For example, in 2 dimensions, it might be x cos y e to the xy. In 3 dimensions, it might look like x squared z sine yz z cubed. Now, a potential function is any function of either 2 variables or 3 variables where, if I take the gradient of the potential function, I will actually get my force vector. And if that's the case, if the gradient produces the force vector, then we say that f is conservative. Now, a conservative vector is the most important type of vector. A conservative force is the most useful type of force. In the previous example, I just made up 2 random vectors. They would not be conservative because they would not have come from a potential function. So an example of this would be, let's say f of x, y, z was simply e to the xy plus 4y squared z. That's a simple function of 3 variables. If I said, what is the gradient of this function? First we take the partial with respect to x. Then we take the partial with respect to y. And then finally the partial with respect to z. And we've created a 3-dimensional vector of force that actually is conservative.